In this video, I want to look at simplifying rational expressions that also have negative exponents in them. And it's actually a group of complex rational expressions. So you end up having fractions and fractions here. It's just a different way to start. So the first thing I would recommend doing is to get rid of those negative exponents and write it actually in fraction form. So for instance, this x to the negative 1 is going to be 1 over x to the first power plus. Now here, just the y has the negative, so the 2x stays where it is, and the y gets flipped down. Oh, sorry, this should be positive 1 there, to 1 in the denominator. Here I have a negative 2, so that x is going to get flipped with a square in the exponent, minus. Now here, both of these have negative exponents, so they will both get flipped down. So the x is squared there, but the y is to the first power. Now, you don't need to write the first power in, so I'm just going to go ahead and clean this up a little bit. So I have 1 over x plus 2x over y, 1 over x squared minus 1 over x squared y. Okay. Now, at this point, you can use whatever strategy you want for complex expressions, right? So now we have a complex rational expression, meaning I have fractions in fractions. I need to clear that out. So one strategy is to go ahead and simplify the numerator and denominator. So you're going to add and subtract, right? Find like terms, common denominators, and then you can go ahead and treat this as division and use the flipping technique. I'm going to use the other strategy, which is simpler here, I think, where I'm going to actually multiply both the top and the bottom by an LCD. And that will be another way that I can simplify here. So again, there's different methods. You can use whatever method you prefer. We do have a full video about how to simplify complex expressions. So if you need to rewatch that, go ahead. But what I'm going to do is I'm going to find the LCD. And the key is that you find it for all fractions. Again, this is just one strategy. So notice I have x's and y's in my denominator, and I also have x squared. So my LCD would be x squared y here. That would incorporate all 4 of the denominators, right? I have the x factor, I have the y factor, I have the x squared, I have the x squared and the y. So they're all being incorporated there. And then what you do is you multiply by that x squared y on top and on bottom. And that reason we do that is because we're keeping it consistent. We're actually multiplying by 1 here because we're multiplying by the same thing on top and bottom. The only thing you have to be careful of is you are going to have to distribute that through to all the pieces. So what you'll have next is you'll have x squared y times 1 over x plus x squared y times 2x over y in the top. And then again, x squared y times 1 over x squared y times 1 over x squared y in the bottom. So that LCD gets distributed to all pieces, basically. Now what happens here is one of your x's will cancel. In this case, your y will cancel. So in the numerator right now, I have an x left, a y, and a 1. So that's going to be xy here. And then in this case, I have a 2, and x times x squared is going to be x cubed. In the denominator, the x squared is going to completely cancel. And here, actually, the whole thing cancels, right? They're both identical. So you end up with just y times 1 is y, and then a minus 1 in the denominator. So this is fine. This is actually your final answer. If you do want to have it in factored form, you could factor an x out of the numerator there because there is an x in common to both pieces. But really, it's the same answer here. It doesn't really do much or help us simplify any further, but they're both considered correct. A lot of times for rationals, we do leave the factored form. So you just want to read through the instructions and see how they want your final answer. But there's nothing more that we can do here to clean this up or to factor and cancel things out. So this would be our final result in this case. All right, let me do one more of these because again, these are a bit tricky and different looking. It's just sort of a hidden way to have those complex fractions. and in complex rationals. So here for the first piece, I do see that the whole thing is to the -1 power. So that's going to be 1 over 2x to the first power, and then plus 1. Here, though, just the x has the negative, so the 2 is going to stay, and just the x is going to flip down. And I'm just going to clean this up for a second. Now, that first power is distributed to both pieces, but because it's the first power, it's not going to change anything. So I have 1 over 2x plus 1, 2 over x plus 1. Again, you could use any strategy you want here to simplify this complex rational expression. So if you wanted to find common denominators and add, you could do that, and then you could use that reciprocal action to complete it. In this case, it's a little bit more complex, so I'm going to stick with the LCD idea here. Now, I only actually have 2 main denominators. I have this one and this one, right? The plus ones don't have anything in the bottom. They would just be ones there. So my LCD would actually be 2x. So 2x fixes this one, and then it also takes care of the x as well. So that's going to be what I'm multiplied by. So multiply this by 2x and this by 2x. And again, just don't forget you are actually distributing that to all pieces. So I would have 2x times 1 over 2x plus 2x times 1. And in the bottom, I have 2x times 2 over x, and then 2x times 1. Here, those two x's are going to cancel. So in the top, I'm left with 1 plus, here again, 2 times 1 is 2, so 2x. In the bottom, just the x's cancel there, so 2 times 2 is 4, and then also I have another 2x. And really, this is everything that we can do here. I can't really see anything else that I can really simplify. I could factor this out in the bottom. So if I try factoring the denominator, we could rewrite it like this. But again, it doesn't really help me cancel anything out. So either form is fine. And this top one is also correct here. And of course, if you wrote the order in a different way, if you want to switch just the 2x plus 1 and 2x plus 4, that's okay too, because I have all positives here and it's all addition. You can rearrange it. But both of these would be considered correct in this case.